The key question here revolves around whether a meter socket or meter adapter-based whole house transfer switch complies with the National Electrical Code, specifically concerning its function as a service disconnect. Based on the description, the device is intended for use with 120/240 volts service and the 240 volts generator input in a non-separately derived system configuration typically found in optional standby systems. The design incorporates interlocking breakers, often a 200 amp service inlet and a 30 amps generator inlet, with the generator connected via a flexible cord. Crucially, the neutral conductor is not switched, and the unit enclosure ground, generator neutral, and generator ground are bonded within the unit. The analysis depends on whether the device qualifies as a service disconnect as defined in Article 100 of the National Electrical Code. Article 230.72 mandates that means shall be provided to disconnect all conductors in a building or other structure from the service entrance conductors. Furthermore, Article 230.75 addresses the disconnection of the grounded conductor, requiring that if the service disconnecting means does not disconnect the grounded conductor, alternative means must be provided within the service equipment. Since the device in question switches the ungrounded service conductors but not the grounded conductor, and it lacks a separate means for disconnecting the grounded conductor, it may not meet the criteria for a service disconnect. If the device isn't a service disconnect, Article 230.82 might apply, potentially categorizing it under other current limiting devices. However, this depends on UL classification of the device as either a meter socket or a meter socket adapter. Article 230.72b regarding additional service disconnecting means might also be relevant if the device were deemed a service disconnect. Given that the device appears to be installed after the service disconnecting means and does not disconnect all conductors, it seems to function more as a transfer switch within the service equipment. Therefore, Article 230 may not be the primary governing section. Instead, Article 702, which covers optional standby systems, is more likely to be applicable. A crucial consideration is Section 702.5c, which addresses flexible cords used for generator connections. This section stipulates that if a generator is connected with a flexible cord, the cord must be listed for hard service and possess the appropriate ampacity. Additionally, the cord must be protected from physical and environmental damage. Listed cord sets with attachment plugs and mating connectors are acceptable under this section. The proper ampacity of the flexible cord must be determined based on the load it will carry. Overcurrent protection must be provided in accordance with the cord's ampacity rating. Flexible cord's length should be minimized to reduce voltage drop and potential hazards. It is also important to ensure that the cord's insulation is suitable for the environmental conditions in which it will be used, such as temperature and exposure to sunlight or chemicals. Furthermore, the connection points for the flexible cord should be readily accessible and properly labeled for safer and easy use. The grounding and bonding of the generator and transfer switch are also critical for safety. The generator's neutral should be bonded to the generator frame, and the transfer switch enclosure should be bonded to the grounding electrode system. This ensures a low impedance path for fault current to return to the source, minimizing the risk of electric shock. The location of the transfer switch should also be carefully considered. It should be installed in a location that is protected from physical damage and environmental hazards such as flooding or extreme temperatures. The transfer switch should also be readily accessible for maintenance and repairs. It is also important to ensure that the transfer switch is properly labeled to indicate its function and the source of power it is supplying. This will help prevent confusion and ensure that the transfer switch is operated safely and correctly. Proper installation and maintenance of the transfer switch are essential for ensuring its reliable operation and preventing potential hazards. Regular inspections should be conducted to check for any signs of damage or wear, and any necessary repairs should be made promptly. It is also important to follow the manufacturer's instructions for installation, operation, and maintenance of the transfer switch. By carefully considering these factors, it is possible to ensure that the generator transfer switch complies with the National Electrical Code and provides a safe and reliable source of backup power. In summary, to determine compliance, firstly, verify if the device meets the definition of service disconnect per Article 100. Secondly, if not a service disconnect, assess its compliance with Article 230.82. Thirdly, ensure adherence to Article 702, specifically Section 702.5c, regarding flexible cords and generator connections. Finally, confirm proper grounding and bonding practices within the system.